All right, Honors Algebra 2 and Algebra 2. This is your first big video here of the Corona quarantine. So, don't know truthfully how long it's going to last, but I'm going to give you videos for everything that I handed out on Thursday and Friday of last week. All right, tomorrow I think the school's open at 10 a.m. for you guys to come in and pick up anything you need, which I highly recommend. Anyway, Honors Algebra 2 and Algebra 2, you have the same game plan. Honors Algebra 2, you have a few extra pages in there, so I'm just going to make one video with this. This is the first game plan that no one has turned in yet. And then I'll just try to put out a video a day or so. All right, here we go. Now, I'm going to go from the beginning, which a lot of you have, so this is something that we should just move through quick. Just plug in. You got exponentials, so forth. If you have a calculator, great. If not, on the iPhone or the Android or iPad, there's different free scientific calculators. All right, so you guys know exponential growth or decay. If it's bigger than 1, it's growth. If it's bigger than 1, just move it over twice. That's 104, which is 4% more. If it's less than 1, it's decay. So move it over twice. That's 91. 100 minus 91 would give you 9% decay. Number 5, move it over twice. That's 113%. It's 13% growth. And then I think you guys get the picture. Move it over. That's 81. 100 minus 81 is 19% decay. Move it over twice. That's 103.5 minus 100, 3.5% growth, and then so forth. We talked about this in a class. Move it over twice, 201. Do 201 minus 100, that's 101% growth. All right, then we got decay, 10%. Yeah, we moved through that once already, so I'm going to kind of go quick. We should have done this one as well. 8.5% annual growth. 1.085 is the base. Raise it to the 10th. You guys got a calculator. Hopefully we do that one anyway. If not, you can type that in quickly when we get back. This will not be due immediately when we get back, but you want to have it done so we can talk about it when you get back, and then we'll go from there. Again, in week 2, I'll give you more definitive due dates and stuff. Anyway, number 13, start of your 10th year, you've had 9 raises. Start of your 30th year, you've had 29 raises. So those are the exponents, 9 and 29. And again, I just didn't type that one in. R-naught factor, 3 to the 7th times 54. It's kind of a timely question now for us. That was a big number. And remember, this was like something trillion. All right. It almost broke our calculator. So let's go next page here. 7.2, solving exponential functions. So here's a little review. Move that over twice. 101.5 minus 100, 1.5% growth. Move that over twice. 9% growth. Move that over twice. Subtract from 100. That is a decay of 0.5%. So regular Algebra 2, you might not have hit this page entirely yet. In order to solve exponential equations, your goal is to get something like this. 2 to the x equals 2 to the 10th. If I had 2 to the x equals 2 to the 10th, I think all of you could tell me that x would have to be equal to 10, and that's our goal, is to get everything to be the same base. Okay, so I can make 3 and 9 be the same base. 9 is 3 squared. So now the bases are equal. Now here I have a power to a power, so I multiply those two powers together. 3 squared, then squared again would be 3 to the 4th. If I have 3 to the x equals 3 to the 4th, then I know x has got to be 4. All right, same type of thing on 5 here. 2 and 16, I want them to be the same base. Well, 16 is 2 to the 4th. I just rewrite 16. It's 2 to the 4th. All right. Now, 2 to the 4th is being raised to the 3rd power, so I multiply those two powers together. That's going to be 2 to the 12th. Subtract 1. You got x minus 1 equals 12. Again, when the bases are the same, then the exponents have to be equal to each other. You know that x minus 1 has got to be equal to 12, so x is 13. 6 is a little bit easier. You could get 4 and 64 to be base 4. 64 is 4 to the 3rd power. So if 4 to the x minus 1 equals 4 to the third, you know those exponents. X minus 1 has got to be equal to 3. So x is 4. All right, some of these you're going to have to practice on your own. Number 8, 16 is 2 to the fourth. 8 is 2 to the third. Here you have a power to a power. You need to multiply it all out. This is now going to be 2 to the 8x minus 12 is equal to the 2 to the third. Add 12 to both sides. Again, when the bases are the same, then the exponents must be equal. 8x minus 12 equals that exponent 3. Now number 9. So the common base is 2. If you know that 2 to the fifth is 32, then 2 to the negative fifth is 1 over 32. X plus 2 has got to be equal to negative 5. And we get x is negative 7. All right, number 10. 27 is 3 to the third. So we got a power to a power. Multiply those powers together. I now have 3 to the 5x equals 3 to the 6x minus 12. Subtract 6x and solve. X is 12. All right, 49 is 7 squared. So we got a power to a power. You already have base 7 here. So base 7, then the exponents, 2x plus 10. It's got to be equal to 8x minus 6. And solve, and there we go. All right. Move on here, next page. All right. Anytime you see 2, you want that to be the common base. So 32 is 2 to the fifth. You got a power to a power, multiply them together. That's now going to be the 2 to the 5x minus 15. Got common bases of 2, so the exponents, 4x plus 1, has got to be equal to 5x minus 15. All right, on 14, you have 10 to the x plus 3 is equal to 10 to the 1, 2, 3, 4. So x plus 3 has got to be equal to 4. There you go. All right, so hopefully we're getting the hang of this right now. There's number 15. 64 is 4 to the third. And you got a power to a power. 4 to the 6x minus 12. So I'm probably going to break this packet into 2 different videos, so it's not all at once. So here you got 4 to the 2x plus 6 is equal to 4 to the 6x minus 12. Again, your goal over this is not just to copy answers, because you're going to get some new content. Like, you're going to have to watch and study. When the bases are the same, the exponents are equal. There you go. On 17, the common base here is not 4, but it's going to be 2. Yes, 16 is 4 squared, but 8 is not 4 to anything, all right, that you want to use. Yes, it's 4 to the 1.5, but you don't want a decimal here. So instead it's base 2. 8 is 2 to the third. 16 is 2 to the fourth. So then you got a power to a power. You multiply those powers, those exponents together, all right. 6x plus 12, 4x plus 4. If the bases are the same, then the exponents have got to be equal. On 18, a fourth is 4 to the negative first. 16 is 4 squared. The bases are the same, so set the exponents equal to each other. And on 19, so 27 is 3 to the third. 1/9 is 3 to the negative seconds. Okay, because 9 is 3 squared, so 1/9 is 3 to the negative second. We got a power to a power. You got 3x minus 3 as an exponent. If the bases are the same, then those exponents must be equal. Again, over this break, make a study buddy. You got plenty of sharp students that can help you out if you need it. You'll be all right. 64 is 2 to the 6th. So we're going to have a power to a power here. Okay, you got 2 to the 66 minus 12x equals 2 to the x minus 1. Bases are the same, so set the exponents equal to each other. When the bases are the same, you can forget about them. 216 is 6 to the third. 1 over 6 is 6 to the negative first. All right, got a power to a power. Negative x minus 3 is equal to that exponent of regular 3. I don't know why. There you go. Add 3 to the other side, you get 6 equals negative x. X is negative 6. 1 over 25 is 5 to the negative second. Get a power to a power, so multiply them together. And the exponents are equal. That exponent equals that exponent. And on 24, 1/2 is 2 to the negative first. 8 is 2 to the third. Get a power to a power, multiply them together. There we go. 6x plus 3. Set those exponents equal to each other. All right, so next page, a little bit of review. It's actually a little bit easier page. And this was Honors Algebra 2 only. So Honors Algebra 2, I know we went over this. Gonna move through it pretty quickly. Again, this page is Honors Algebra 2 only. So Algebra 2, just take a pause, all right? Again, Honors Algebra 2, we should have done this in class. You guys should have done this in class. All right, so if I'm going too fast, pause it. Honors Algebra 2. Honors only. All right. Next page is also honors only. So there's that. And there's number 15. Some videos we have sponsors. This one's been made a little late. Sponsors have gone to bed. There's 17. Can't get the exponents. Get the bases to be the same. Get the bases to be the same. Again, keep up on your work, folks, or else it's going to be a really difficult transition back. All right. Verse 21. All right, we should have, anyway, on the money page here. Start of your 16th year, if you had 15 raises. 3% raise is 1.03. That's going to be raised to the 15th, 15 straight of them. 25 straight of them, 35 straight of them. Okay, deposit $15,000 after 15 years, 1.099% rate of return on average. After 30 years, it'd be that. Whoa. Put 1.5 million, 8% for 20 years. It's a lot of money. And 5% interest daily after 7 days. You'd have to owe back that. All right, so Honors Algebra 2, you should have done the second page. This next page, Algebra 2, you get free points. Just put Go Salukis down as your answer for your points. On number 2, Honors Algebra 2, you should have done this already. Regular Algebra 2, put SIUC greater than or equal to SIUE. Yep, sorry. If you want the points, that's what you got. All right, next page. For Algebra 2, free points, answer equals we love the Avett brothers, which you do. All right, then this is section 7.3, so I'm going to start the next video with section 7.3. Yakumath videos out.